Okay, so good day and welcome to our virtual class, week 2. Our topic is cognitive aspect. So overview of our lesson. What is cognition? What are users good and bad at? Describe how cognition has been applied in interaction design, mental models, internal classic theories of cognition, and more recent external theories of cognition. Okay, so why do we need to understand user? First, interacting with the technology is cognitive. So you need to take into account cognitive processes involved and cognitive limitation of the user. Third, it provides knowledge about the user can and cannot be expected to do. It identifies and explains the nature and causes of problems user encounters. It supplies theories, modeling tools, guidance, and methods that can lead to a design better interactive products. So effective user experience start with a good understanding of your user. So not only do you want to know who they are, but you want to dive deeper into the understanding their motivation, mentality, and behavior. This deep insight into your user will help you keep your product focused on the delivering of a great experience. So the better you understand your user, the more likely you are to design and build a service that work well for them. Who are our user? They are people who need to use the services you are working on. So if you want to design a successful product for people, first of all, you need to understand them. It sets goals, create visibility of the problems and potential issue in the user product. So cognitive process, okay, so we have the attention, perception and recognition, memory, learning, reading, speaking, and listening, problem solving, planning, reasoning, and decision making. Okay, so cognition is a term referring to the mental processes involved in gaining knowledge and comprehension. So these cognitive processes include thinking, knowing, remembering, and judging and problem solving. So these are high level function of the brain and encourage language, imagination, perception, and planning. Cognitive psychology is a field of psychology that investigate how people think and the process involved in cognition. So we have attention. Okay, so attention. So first is selecting things to concentrate on at a point in a time from the mass of stimuli around us. It allows us to focus on information that is relevant to what we are doing. It involves audio and or visual senses. Focus and divided attention enable us to be selective in terms of the mass of competing stimuli but limits our ability to keep track of all events. Information at the interface should be structured to capture user attention. Example, use of perceptual boundaries or windows, colors, reverse video, sounds, or flashing lights. Again, attention is a cognitive process that allows people to focus on specific stimulus in environment. Attention is the ability to actively process specific information in the environment while tuning out other details. Attention is limited in terms of both capacity and duration. So it's important to have ways to effectively manage the attentional resources we have available in order to make sense of the world. Okay. Example, activity, find the price of the double room at the Holiday Inn in Bradley. Okay, so try to find the price. Okay, next. So find the price for the double room at the Quality Inn in Colombia. So try to, okay. So after you try, okay. So after you look at the figure, Okay, then you find the price for double room at a Quality Inn in Colombia and South Carolina, and to find the phone number of days in a Charles Town, South Carolina. Then look at the bottom screen in a figure 4. Find the price of the double room at the Holiday Inn in Bradley, Pennsylvania, and find the phone number of uh, the Quality Inn in Bedford, Pennsylvania, which took longer to do. Okay, so in early study, tourists found that the two screens produce quite different results. Okay, so it took an average of 3.2 seconds to search the top screen, while it took an average of 5.5 seconds to find the same kind of information in the bottom screen. So why is this so? So considering that the both display have the same density of information relative to the background. Okay, so the primary reason for the disparity in the way that the characters are grouped in the display. So in the top screen, so yung first leg na, they are grouped into a vertical categories of information. That is place, type, of accommodation, phone number, and rates. And this screen has space in between the columns of information. So in the bottom screen, the information is bunched together, making it much more difficult to search. Okay, so multitasking and attention. So it's possible to perform multiple tasks without one or more of them being detrimentally affected. So offer research compare heavy versus light multitasker. So heavy were more prone to being distracted than those who infrequently multitask. Heavy multitasker are easily distracted and find it difficult to filter irrelevant information. Okay, so research has demonstrated that the switching from one task to the next takes a serious toll on productivity. Okay, so multitasker have more trouble tuning out distraction than the people who focus on one task at a time. Also, doing so many different things at once can actually impair cognitive ability. Okay, in multitasking, it creates a greater demand for cognitive resources, such as attention and working memory. So our brain activates more resources to meet the increased demand. So because multitasking decreases your brain efficiency and mental performance, your productivity level also decline. So doing two tasks at once has been found to reduce the productivity. Design implication for attention. Okay, so make information silent when it needs attending to. Use techniques that make things stand out like color, ordering, spacing, underlining, sequencing, and animation. Avoid cluttering the interface with too much information. And avoid using too much because software allows it. Okay, so information at the interface is structured to capture user attention. Okay, so for example, yung perceptual boundaries, yung mga colors, video, and sound and flashing light. So avoid sabi nga, using too much distraction para sa mga viewers. Okay, so this one. So this example, okay, example of overuse graphics. So bad graphic designs comes in many forms, such as an ugly color scheme or too much clutter. Okay. Then we have the perception. Okay, so how information is acquired from the word and transformed into experiences. Obvious implication to its designs, representation that are readily perceivable. Examples, text should be legible, icons should be easy to distinguish and read. Perception is the sensory experience of the world. It involves both recognizing environmental stimuli and action in response to these stimuli. So through perception process, we gain information about the properties and elements of the environment that are critical. Perception describes the process by which we gather information from our surrounding using our senses. Sample vision and hearing dominate interaction. So if we cannot see a display or hear a warning, then we are unlikely to respond correctly. Issues such as font designs are key concern of HCI or human computer interaction. And like I said, perception is what the user see and feels when they are using HCI. Okay. To help us see, feel, and use HCI Designer, use color, patterns, and objects. For example, color can determine if the user should be careful or not, or if the user need to take action within the HCI, or it can also tell the user that there is nothing wrong to worry about. Designers use color to help user use HCI. So it's natural for us as a human to think that red means dangerous, yellow means be careful, and green means that everything is fine. And designers use this to their advantage and to help us to make HCI more easy to use. Uh, Here are example natin. Okay, so for example, I use an antivirus. Okay, so when the antivirus detects no virus and also detects that it is up to date, it will display secured. So in green, writing, okay, because the writing is green and also read secured, it makes me feel more secured and safe. Okay, so when a virus is detected and action need to be taken, it will display not protected in red writing. So the red writing indicates within itself that the action need to be taken. Okay, so the red writing also makes feel unsafe. As well as drawing attention to a user and notifying user, colors is also used in HCI to improve navigation. Okay, so by using color consistently, it can help us user to navigate to find the right information. So it's another example. It's color contrast. Okay, then find Italian. So try to find the Italian. Okay, are borders and white space better than find French? Okay, try to find French. Okay, so Weller, okay, in the research of Weller, found people took less time to locate items for information that was grouped. So using border, the second screen, compared with the using contrast in the first screen. Some argue that too much white space on the web is detrimental to search, make it hard to find information. Okay, so guys, do you agree? Okay, so when elements are placed in group that defines an object, we tend to see the group and not the elements. So, okay, so micro white space has a direct impact on the content legibility. For example, marginal white space surrounding paragraphs affects the user reading speed and comprehension. So if text appears in margin outside regular paragraphs, people read it more slowly. So they find it harder to understand than text without such margin. So example, which is easiest to read and why? Okay. So design implication. Okay, so icons should enable user to readily distinguish their meaning. Okay, bordering and spacing are effective visual ways of grouping information. Sound should be audible and distinguishable. Speech output should be enable user to distinguish between the set of spoken words. Text should be legible and distinguishable from the background. Tactile feedback should allow user to recognize and distinguish different meaning. Okay, so icon, sabi nga, must first and foremost communicate meaning in a graphical user interface. Icon should pass to recognize at a glance. Then bordering and spacing are effective visual ways of grouping information that makes it easier to perceive and locate items. Okay, and the principle of grouping or the Gestalt law of groupings, okay, are set of principles in psychology first proposed by Gestalt, a psychologist, to account for the observation that humans naturally perceive objects as an organized pattern and objects, a principle known as fragment. Just as psychologists argue that this principle exists because the mind has an innate disposition to perceive patterns in the stimulus based on a certain rules. Okay, so design audio sounds to be readily distinguishable from one another so that the user can perceive how they differ and remember what each one represents. And research proper color contrast techniques when designing an interface, especially when choosing a color for text so that it stands out from the background. For example, it's okay to use yellow text on a black or blue background. So, but not on a white or green background. Then yung dito, yung tactile feedback. Uh, Tactile feed should be used judiciously. So the kind of haptics used to be easily distinguishable so that, for example, the sensation of squeezing is represented in a tactile form that is different from the sensation of pushing. Okay, so overuse of haptics can cause confusion. Okay, so Apple iOS suggests providing haptic feedback in response to the user-initiated action, such as when the action of unlocking a vehicle using a smartwatch has been completed. Okay. Then we have memory. So memory involves the first encoding and the retrieving knowledge. Okay, we don't remember everything. Involves filtering and processing what is intended to. Context is important in affecting our memory. When and where and when. We recognize things much better than being able to recall things. Okay, so memory involves recalling various kinds of knowledge that allow people to act appropriately. For example, it allows them to recognize someone's face, remember someone's name, or recall why they uh, when they last met, okay, and know what they said to the last, or know what they said to them last. It is not possible for us to remember everything that we see, hear, taste, smell, or touch. Okay? Nor would we want to, or our brains we get overloaded. So filtering process is used to decide what information gets further processed and memorized. This filtering process, however, is not without its problem. Often we forget things that we would like to remember, and conversely, remember things that we would like to forget. For example, we may find it difficult to remember everyday things like people's name or scientific knowledge such as mathematical formula. Or on the other hand, we may effortlessly remember trivia or tunes that cycle endlessly through our heads. Okay, so processing in our memory. Okay, so encoding is the first stage of memory. Okay, determine which of information is intended to in the environment and how it is interpreted. So the more attention paid to something, the more it processes in terms of thinking about it and comparing it with other knowledge. Okay, the more likely it is to be remembered. Example, when learning about HCI, it's much better to reflect upon it, carry out exercises, have discussion with other about it, and write notes than just passively read a book. listen to a lecture, or watch a video about it. Okay, so how does this filtering process work? So again, initially, encoding takes place uh, determining which information is paid attention to in the environment and how it is interpreted. So the extent to which it takes place affects people's ability to recall that information later. Okay, the more attention that is paid to something and the more it is processed in terms of thinking about it and comparing it with other knowledge, the more likely it is to be remembered. Okay, so for example, when learning about a topic, it's much better reflect on it or carry out exercises. So context is important. Okay, context affects the extent to which information can be subsequently retrieved. Sometimes can be difficult for people to recall information that was encoded in different contexts. Example, you are on a train and someone comes up to you and say hello. So you don't recognize him for a few moments, but then realize it is one of your neighbors. You are only used to seeing your neighbor in the hallway of your apartment block, and seeing him out of the context makes him difficult to recognize initially. So this is another factor that affects the extent to which information can be successfully retrieved. So in the context in which it's encoded, one outcome is that sometimes it can be difficult for people to recall information that was encoded in a different context from the one in which they are at present. Okay? Like yung scenario na binasa natin kanina. Recognition versus recall or recall. So command-based interfaces requires user to recall from memory name from possible sets of 100s. GUIs provides a visually based option that user need only browse through until they recognize one. Web browser MP3 players provide lists of visited URL song titles that support recognition memory. Another well-known memory phenomenon is that people are much better at recognizing things than recalling things. Furthermore, certain kinds of information is easier to recognize than others. So in particular, people are good at recognizing thousands of features even if they have only seen them briefly before. In contrast, people are not as good at remembering details about the things they photograph when visiting places such as museum. Okay, it seems that they remember less about objects when visiting places or when they have photographed them than when they observe. Okay. The reason for this is that the study, participants appear to be focusing more on framing the photo and less on the details of the object being photographed. Consequently, people don't process as much information about an object when taking photos of it compared with they are actually looking at it. Okay. Then personal information management. Personal information management is a growing problem for many users. So vast number of documents, image, music files, video clips, email, attachment, bookmark, where and how to save them, and remembering what they were called when where to find them again, naming most common means of encoding them, but can be difficult to remember, especially when have 1,000 or thousands of sabi nga, files. So how might such a process be facilitated taking into account people's memory abilities? Okay, so the number of documents, okay, documents written, image created, music files recorded, video clips download, emails with attachment saves, URL bookmark, and so on, increase every day. A common practice is for people to store these files on a phone on a computer or in a cloud with a view to accessing them later. This is known as Personal Information Management, or PIM. So the design challenge here is deciding which is the best way of helping user organize their content so that it can be easily searched, for example, via folder, albums, or lists. Okay, the solution should help user readily access a specific item at a later date. For example, a particular image, video, or document. So this can be difficult. However, especially when there are thousands or hundreds of thousands of pieces of information available. Offer Wegman and Steve Whitaker have proposed a model for helping people manage their digital stuff based on curation. So the model involves three independent processes. First, how to decide what personal information to keep. Second is how to organize the information when storing it, and which strategies to use to retrieve it later. Okay, so the first stage can be assisted by the system they use. For example, email, text, music, and photos are stored as default by many devices. Users have to decide whether to place these in folders or delete them. So in contrast, when browsing the web, they have to make a conscious decision as to whether a site they are visiting is worth bookmarking as one, or they might want to revisit later. So a number of ways of adding metadata to documents have been developed, including time-stamping, categorizing, tagging, and attribution. For example, a color, text, icon, sounds, or image. Then we have the application. So speech recognition systems allows user to interact with them by using spoken command. Example, si Google Voice Search app. So speech out system natin. Okay, so yeah. So many applications has been developed either to capitalize on people's reading, writing, and listening skill, or to support or replace them where they lack or have difficulty with them. Yung speech recognition system is the ability of machine or program to receive and interpret or understand and carry on spoken commands. It enables a consumer to interact with the technology simply by speaking to it, enabling hands-free requests, reminders, and other simple tasks. For example, yun nga, si Google Voice Search, Dragon Home, okay, and iba mga device meron din such as Amazon Echo, Google Home, and ano pa ba? Okay, so speech output is now available on all computer and devices. It has considerable benefits for people with learning difficulties and disabilities, as it provide additional reinforcement, motivation, and feedback from the computer. However, the software being used has to be capable of producing a speech output. Example, text-to-speech output is accessibility service for Android, which convert language text into spoken synthetic speech using inbuilt screen reader software. So this means a user is able to type in content and have a read back them aloud and automatically. Okay, then we have here the natural language system. So enable user to type in question and give text box responses. Okay, so a natural language interface that enable people to type in question and get a written responses. Ang sample nito is yung mga chatbots or chatbots natin. Okay, so yung a chatbot is a software application used to conduct online chat conversation via text or text-to-speech. Okay. A chatbot is a computer program designed to simulate human conversation. Users communicate with these tools using a chat interface or via voice, just like they would converse with another person. So chatbots interpret the words given to them by the person and provide a preset answer. So okay, exercise 8 p.m. Okay, let's skip. Okay, so goal of execution and evaluation. Okay, so the goal implicates the gap that exists between the user and the interface. The goal of execution is the distance from the user to the physical system. Okay, so the goal of evaluation is the distance from the physical system to the user. Bridging that gaps can reduce cognitive efforts required to perform tasks. Okay, so a number of conceptual frameworks have been developed to explain and predict user behavior based on tourist cognition. Explains how human interacts and use technologies in contexts in which they occur. These are mental models, goal of execution, and evaluation. Again, so the goal of execution and the goal of evaluation describe the gaps that exist between the user and the interface. So the goals are intended to show how design the later to enable the user to cope with them. The first one, the goal of execution, describe the distance from the user to the physical system, while the second one, the goal of evaluation, is the distance from the physical system to the user. So bridging the goal. Don Norman and his colleagues suggest that designers and users need to concern themselves with how to bridge the goals to reduce the cognitive effort required to perform a task. This can be achieved on the one hand by designing usable interface that match the psychological characteristic of the user. For example, taking into account their memory limitation, and on the other hand, by the user learning to create goals, plans, and action sequence that fit with how the interface works. Okay, so again, goal evaluation. This is what the current system state, and the goal of execution is how do I use this system. Okay, so information processing. Conceptualize human performance in metaphorical terms of information processing stage. So may we have the input or the stimuli, the encoding, the first stage. Second stage is the comparison. Third is the response selection. Fourth is response execution, output or response. So another approach to conceptualizing how the mind works has been used metaphors and analogies to describe cognitive process. The numerous comparisons have been made, including conceptualizing the mind as a reservoir of a telephone network, a digital computer, and a deep learning network. One prevalent metaphor from cognitive psychology is the idea that the mind is an information processor. Information thought is to enter and exit the mind through a series of order processing stages. Okay. So within this stage, various processes are assumed to act upon mental representation. Processes include comparing and matching. Mental representation are assumed to comprise image, mental models, rules, and other forms of knowledge. Okay, so the information processing models provide a basis from which to make prediction about human performance. Hypotheses can be made about how long someone will take to perceive and respond to a stimulus, also known as the reaction time, and what bottlenecks occur if a person is overloaded with too much information. So one of the first HCI models to derive from the information processing theory was the human processor model, which modeled the cognitive process of a user interacting with a computer. So the information processing approach was based on modeling mental activities that happen exclusively inside the head. So nowadays, it's more common to understand cognitive activities in context which they occur analyzing cognition. So model of human processor. Okay, models information processor of a user interact with the computer. Predicts which cognitive process are involved with the user interact with the computer. It enables calculation to be made of how long a user will take to carry out a task. Again, human processor model, okay, is a cognitive modeling method developed by Stuart K. Card and Thomas V. Moran and Alan Newell, used to calculate how long it takes to perform a certain task. This method is used experimental times to calculate cognitive and motor processing time. It is design tool that is used for creating an effective user interface. It draws an analogy between processing and storage facilities in a computer system with perpetual cognitive, memory, and motor activities of a computer user. Human processor model, which models the cognitive process of a user interacting with a computer, is based on the information processing model. Cognition is conceptualized a series of processing stages where perceptual, cognitive, and motor processes are organized in relation to one another. So the model predicts which cognitive processes are involved when a user interacts with the computer, enabling calculation to be made how long a user will take to carry out a various task. So this can be very useful when comparing different interfaces. For example, it has been used to compare how well different word processors support a range of editing tasks. Okay, so limitation. So based on modeling, mental activities that happen inside the head do not adequately account for how people interact with computer and other device in a real world. Okay, so however, most cognitive activities involve people interacting with the external kind of representation like books, documents, and computers, not to mention one another. For example, when we go home from what wherever we have been, we do not need to remember the details of the route because we rely on cues in the environment. Okay, so do they adequately account for cognition that happens in the real world? And specifically, how people interact with the computer and other interactive devices. Several researchers have argued that existing information processing approaches are too impoverished. Okay, then we have the external cognition, concerned with explaining how we interact with the external representation, sample maps, notes, diagram. What are the cognitive benefits and what a process involves? How they extend our cognition? What computer-based representation can we develop to help even more? Okay, so people interact with or create information through using a variety of external representation. Again, example is book, multimedia, newspaper, web pages, maps, diagram, notes, drawing, and so on. Furthermore, an impressive range of tools have been developed throughout history to aid cognition, including pens, calculator, and computer-based technologies. The combination of external representation and physical tools have greatly extended the support people ability to carry out cognitive activities. Okay, so indeed, they are such an integral part that it's difficult to imagine how we would go about much our everyday life without them. Again, external cognition is concerned with explaining the cognitive process involved when we interact with different external representation. So main goal to explicate the cognitive benefits of using different representation for different cognitive activities and the processes involved. So the main ones include first is externalizing and reduce the memory load. Second is computational uploading and annotating and cognitive tracing. Okay, so annotation and cognitive tracing. So annotation involves modifying existing representation through making marks, example, crossing off, ticking, or underlining. So cognitive tracing involves externally manipulating items into a different orders of structures, example, playing Scrabble and playing cards. Okay, let's see. So another way in which we externalize our cognitions by modifying representation to reflect changes that are taking place that we want to mark. Uh, for example, people often cross things off to the list to indicate tasks that have been completed. So they may also reorder objects in the environment by creating different files as the nature of the work to be done changes. Okay, so these two types of modification are called annotating and cognitive tracing. Again, annotating involves modifying external representations such as crossing off or underlining items, and cognitive tracing involves external manipulating items into different order or structure. So annotating is often used when people go shopping. People usually begin their shopping by planning what they are going to buy. So this often involves looking in their cupboards and fridge to see what needs stocking. However, many people are aware that they won't remember all these there in their heads. Okay, so they often externalize it as a written shopping list. Lack of written may also remind them of other items that they need to buy, which they may not have noticed when looking through the cupboards. So when they actually go shopping at the store, they may cross off items on the shopping list as they are placed in the shopping basket or cart. So this provides them with annotated externalization, allowing them to see at a glance what items are still left on the list that may need to be bought. Um, there are numbers of digital annotation tools that allow people use pens, styluses, or their fingers to annotate documents such as circling data or writing notes. The annotation can be stored with the documents, enabling the user to revisit their or other externalization at a later date. Then the cognitive tracing is useful in condition where the current situation is in a state of flux and the person is trying to optimize their position. This typically happens when playing games such as the following. So in a card game, when the continuous rearrangement of hand of cards into suits in ascending orders, or collecting same numbers together helps determine what cards to keep and which to play as the game progress and the tactics change. Another example in Scrabble, where shuffling letters around in the tray helps person work out the best word given the letter set. So cognitive tracing has also been used an interactive function. Excuse. For example, letting students know what they have studied in online learning package. An interactive diagram can be used to highlight all the nodes visited, exercises completed, and units still to be studied. So design application for its provide external representation at the interface that reduce memory load and facilitate computational uploading. So information visualization have designed to allow people to make sense and rapid decision about matters data. Summary. Okay. Cognition involves several processes including attention, memory, perception, and learning. The way an interface is designed can greatly affect how well user can perceive, attend, learn, and remember how to do their tasks. Theoretical frameworks such as mental models and external cognition provide ways of understanding how and why people interact with the product. So this can lead to thinking about how to design better products. A general cognitive principle for interaction design based on the external cognition approach is to provide external representation at interface that reduce memory load, support creativity, and facilitate computational uploading. So different kinds of information visualization can be developed that reduce the amount of effort required to make interferences. So for example, about a given topic, so financial, forecasting, identifying programming bugs. In so doing, they can extend or amplify cognition, allowing people to perceive and do activities that they couldn't do otherwise. Um, for example, information visualization. Okay, so these are used to represent big data in visual form that can make it easier to make cross comparison across the dimension and see patterns and anomalies. Workflows and contextual dialog box can also pop up at appropriate times to guide user through their interaction, especially when there are potentially hundreds and sometimes thousands of options available. So this reduces memory load significantly and free up more cognitive capacity for enabling people to complete desired tasks. Okay, so that's it. And thank you.